Hey guys, it's Mr. Win, and I'm going to show you how to graph linear inequalities. Alright, so we know these are linear functions. That means we want to get every equation into slope-intercept form. Okay, that's the easiest form to graph because if you have it in y equals mx plus b, you can easily tell that your m is going to be your slope. That's simply just rise over run. And b would be your y-intercept. So it'd be the point, it'd be that number where it crosses the y line, the y-axis, all right? A couple rules as well, though. These are all inequalities, so you won't be seeing these equal signs, okay? You won't be seeing equal signs, but you will see less than and greater thans. So if you have a less than or a greater than, it changes how your line looks. The line will now be dashed, okay? That means it's not equal to, it means the line is technically not there, but you want to show that boundary. If you have less than or equal to and greater than or equal to, you see the line underneath the symbols? Your line will be solid, okay? And not only do you change the line, but you actually have to show a region that's shaded. So like if you say something is less than 5, that means it's everything below that. 4, 3, 2, 1, 0, negatives, everything below that. So you got to show that every number below that, you shade that area below 5. So in this case, if you have less than or equal to, it makes sense to shade below because it's less than those numbers, right? If you have a greater than symbol or a greater than or equal to symbol, you shade above. All right, so there's kind of like 3 steps to this. All right, you always want to make sure it's a slope-intercept form. Make sure what type of line it is, and then where you shade. All right, so looking at example 1, or this is actually example 2 from the notes. All right, notice it's already in slope-intercept form because you already have y isolated. All right, this y is already alone. Right, that's the main thing about slope-intercept form. You always have that y alone. So if the y is isolated, y is alone, it's already in slope-intercept form. That means we know 3/2 is going to be your slope. Okay, that means when I graph the points, you're going to be rising 3, running 2, and you know -1 is your y-intercept. So that's where you start, right? So that's your y-intercept, right? You would start it at 0, -1. So you start your point at -1 here. All right, then we know the rise over run is 3 over 2. So that means we rise 3. So from that point, 1, 2, 3, run 2, 1, 2. There's your next point. All right, now you can keep continuing that pattern, up 3 over 2, even go backwards. We know it's going to be a straight line. All right, so that's what it's going to look like. All right, and then from here, you want to look at your symbol. All right, so I'm going to kind of erase this to show our symbol. But your symbol here is a less than or equal to. Notice that line underneath, all right? That means it's or equal to. That means you will actually have that line on there. It's actually going to be a solid line. So anytime you see that symbol, right, less than or equal to here, right, we're going to have a solid line and we're going to shade below. So let's draw in our solid line. Right, and then shade below. So below the graph, always think up and down. Right here would be below. All right, so there's really not too much of a change when we're graphing, just like you would graph normally, but you just got to pay attention to what type of line is it going to be and where you're going to shade. Okay, here's another example. This is example 3 from the notes. Again, our first step was to find out if it's in y-intercept form. And notice how the y is not isolated, right? This is what we want alone, right? So that means we got to get rid of this -5 and that -2, all right? So I'm going to rewrite the problem. I've got -5, x minus 2y is greater than -4. All right, so canceling out the -5x first. And again, I'm saying cancel, so we do the opposite. So add 5x to both sides. This cancels, you're left with -2y is greater than, well, notice you can't subtract, well, you can't add 5x to a 4 because they're different. So I'm just going to write 5x first, and then that's a negative 4, so minus 4. All right, the next step is you want to cancel that negative 2, right? You're kind of separating that from the y, so only that negative 2. So this is where you got to divide. So I'm separating them, I'm dividing them. I'm going to divide that by negative 2, so divide everything by negative 2. All right, so this cancels, right? So our equation is actually going to be y, okay? And it's actually going to be less than. Notice how the sign changes, okay? So if you remember from doing inequalities, when we solved inequalities, that the special rule is you have to flip the sign if you divide by a negative. So I'm going to write a little key here. That should be a star. That you have to flip sign, okay, if you divide by negative. And we just did that here, okay? You won't always divide by negative, okay? It really depends on what number is in front of that y. It could have been positive. If you divide by positive, leave the sign alone. Only when you divide by a negative. All right? So I'm going to go ahead and divide this, and let's just leave 5 over 2 as a fraction, because that's fine. We know rise over run fractions are okay. And negative 4 divided by negative 2, they're both negative, so it will be a positive 2. All right, this is the equation we're going to graph. So that tells me that the slope, your rise over run, is going to be negative 5 over 2. And it also tells you your y-intercept will be 2. So you're going to start at 0, 2. Okay, so at 0, 2, here's our point. And we're going to rise 5, run 2. So in this case, we're rising negative 5. So go down 5. 1, 2, 3, 4, 5. Run 2, 1, 2. There's your next point. All right, now look at your symbol. Remember our new symbol's right here. Okay, this is our new symbol. It is a less than symbol, right? It is less than. And notice there's no equal sign underneath, right? There's no line here, right? I drew that in, but that's not there, okay? So that means your line is technically not there. It's not actually equal to your line. So, but you want to show that boundary, so I'm going to draw a dashed line. Okay? It is actually, there's no line there. That line is not actually there, but you want to show where it would be. So again, less than symbol, right? Here's our symbol, it's dashed, and we're shading below, okay? So I drew a dashed line, let's shade below, and below the line would be this area. All right, so let's just shade everything in. All right, and we're good, we graphed the inequality. All right, what if I'm asking you for solutions, okay? Solutions, right? Solutions are any point within the shaded area. So say over here, back to example 2, any points there could be solutions. So if I ask you to find 2 solutions, you could just pick points like say, I don't know, this is a good point, 2, negative 1, okay? Or even out here, 4, 2. Right, any points here. There's numerous points that you could choose from. 1, negative 3, right? Any of those points would work. Okay, so same thing here. Any point in here would work. However, if I give you an equation, okay, and I give you the solutions, like say this is our equation, 3x minus 2y is less than 12, and then we give you the solution, negative 1, 3. Notice you always have an x and a y, right? So if you plug these numbers in, okay, into your equation, find out if that statement is true, and you'll know, if it's a solution or not. So like say, for example, our equation was 3, and then x instead of x, we'll write negative 1, minus 2, and then instead of y, we'll write 3. Is that going to be less than 12? Well, if I multiply it out, 3 times negative 1 is negative 3. Negative 2 times 3 is negative 6. Okay, and is negative 3 minus 6 is negative 9. Is that less than 12? Yes. All right, negative numbers are definitely less than a positive 12. It is true. That means that this point, yes, is a solution. Okay? Do the same thing here. X, y, plug those in. So 3, instead of x, I'll write 2. Minus 2, and then instead of y, I'll write negative 3. And is that going to be less than 12? Well, 3 times 2 is 6. Negative 2 times negative 3 is 6 too. It's positive. And if I add those numbers, 6 plus 6, 12. Is 12 less than 12? Well, no, right? 12 is equal to 12, but it's not less than, right? So it's false. This is not a solution to our equation. All right, and that is it about how to find solutions, how to graph these inequalities. These are in your notes through Google Classroom, and that's it. Thank you.